Welcome to chapter 6 of this microcontroller development board building. So here we'll discuss about how we can introduce headers for general purpose IO on the PCB and connect the headers to the actual pin layout of the microcontroller. So the pin layout of the microcontroller is 16 pins. It starts from left 1 and ends at right 16, so 8 pins each. So we'll follow the same layout for our microcontroller as well, microcontroller PCB. Here if you see, I have already named the pins. These are all labels, right? I'm just taking the same pin names and putting it here, right? So next what we can do is we can introduce a 8 pin on each side. So here let's say I'm taking connector 8 pin, and we can utilize the same 8 pin here and put the same names. Here I have done it. The right side also has similar tags, right? So once that is done, this becomes the right and the left side of the headers. So we have same pin numbers here and the same pin numbers here. I'm utilizing connectors of 2.54 mm width between two legs of the connector because that's what is friendly with breadboards. So that's what I've done. One change which I'll be doing is the second pin connects to VCC. It doesn't directly connect to 5 volts, although the solder jumper here makes it connect directly to 5 volts. I'm just taking a precaution that if we want, we can just cut the connection here and have a Schottky diode pass through for the same when we are using external power for this. Alright, here I have put in a series of 0603 LED with 0603 resistor. The resistor is of 1 kilo ohm. So this particular set is to know that my breadboard, sorry, not the breadboard, my PCB is receiving power. So whenever someone plugs in a USB connected to power, this glows in, right? This I'm connecting it to P3 3.0 so that whenever we have current or will have a programmable capability for P3.0. Okay, one quick thing I want to make sure here is P3.0 is capable of PWM. Yes, it is capable of 3 PWM. So we can even control the intensity of this particular LED, right? So that's covered. So what have we all covered right now? We have covered let me go back to this particular slide that we had written down. PWM, USB programming, UART, capacitive touch. Okay, let's go back to capacitive touch. So capacitive touch, let's go back to this particular sheet and see which pins have capacitive touch. So 8th pin doesn't have capacitive touch. Yeah, TIN1. Okay, let's say this particular pin. 9th pin has capacitive touch. So let's build a capacitive touch probe for this. So for that, let's go back to footprint editor, footprint symbol editor first. So we need let's say file new library. We require this for the project. Let's say this project touch pad. So touchpad is there, so we need a new symbol here, symbol name deriving from test. Let's not derive it from anything and say that here. So this we need to rename. Rename symbol. Let's say it as touchpad PC, and let's create a pad for this. Pin name TP. Pin number 1. Input pin, and we can place it here. So that would be the symbol. So for this we need to have the right symbol properties. We need to have the footprint. So let's close this for now. Let's create a footprint for that. Come on, it's taking a second. Okay, we're back. So let's create a new footprint, new library. Sorry. Let's add, or we should have touchpad here. Test point. Add library project. We do not have any library here, so we can create a new footprint. So the footprint should have a particular pad. One pad is enough for this. The pad size should be a bit bigger. So let's say the pad size should be around rectangle 2 mm cross 2 mm. SMD itself, we want F masks, and we do not require F paste. So this needs to be completely masked. So once we go to 3D view of this, this is how it has to look. So if I enable, let's say enable paste and F mask for this, then it looks something like this. So we don't require that. So if I just enable F mask, it looks like this. So I don't require this mask as well. So the PCP mask, solder mask, needs to be on top of it. So I'm just creating this like this. So this is 2 mm by 2 mm, or I can make it a bit bigger as well. Let's make it 3 mm by 2 mm. Okay, this looks good. We can save this. So library project, touchpad So within touchpad we have this TP1 which is cut. So let's close this, go back to symbol editor. We have this touchpad. So I need to have a footprint for this. So I will go here, TP. So this is the touchpad one. So let's save this. Now coming back to this, let's import that touchpad here. So we can have that here. For the sake of simplicity, let's have that here itself. So this 8th pin is touch sensitive, so we can take that pin 1.1 and connect to this. So we have this touch peripheral interface done. So what have we achieved here? Let's go back and quickly recap. I have a USB-C connection which I have grounded. I have negated these two pins because we would not be using it. We have data plus and data minus connected. We are negotiating power of only 5 volts. V bus is connected to VCC. Here we have headers which are connected to each pin directly. We have our boot and reset buttons. This is a safeguard for USB data lines using Zener diodes of 3.3 volts. A Schottky diode placed between VCC and 5 volts. When we are using VCC as external, we'll enable the Schottky diode. Otherwise, we'll just go with the solder jumper if we are directly going with USB. This is a decoupling sector for decoupling 3.3 volts and 5 volts. Here we have power on notification LED, a LED which we can control on our own, and a touchpad and the microcontroller. So this is what we have done till now, till the topic of chapter 6, that is GPIO and Headers. So in the next chapter, we'll see how do we finalize all this together, put remarks for each and everything, and make a good looking PCB schematic. Thank you.